it's a beautiful day, let's call into work and we'll go out and play, sweet darling. 'Cause I've got nothing but time on my hands, I just wanna spend a little time with my man, sweet darling. You grab the rocks and I'll get the bait. We'll do a little fishing, let's make it a day with the blue skies above and the sun on our skin. Oh, sweet darling, let's go fishing.
Okay, so I'm here with Eleanor Gee, and I want to ask you our interview question. So, how were you first introduced to the idea of ecohydraulics?
I think actually during my undergrad degree, I did civil and environmental engineering, but I had a lecturer who was really into the interface between, pure hydraulics and just the ecology of organisms, and that was kind of, I knew from then on at some point I'd do a PhD kind of in that field, and that's what ecohydraulics is. Yeah.
Yep. Okay, what's an example of an ecohydraulics research article that influenced your research?
Well, I did my PhD in larval dispersal in estuaries, looking at the influence of the salinity structure, and during that time, I think it was in 2012, an article came out by Fernando Anduta and Michael Kingsford and Eric Wolanski looking at essentially kind of sticky water turbulent structures within reef mosaics and how they tend to retain fish larvae within their spawning area, and it was just like, it's just a neat piece of research in terms of the way it was executed, and the findings are really cool. So yeah, that.
And what's an example of a research project that you're working on now?
At the moment, I'm starting work on some fairly fundamental ecology work around some of the New Zealand fish species and how fast they can swim and how long they can swim for at certain rates. We also are interested eventually in looking at fish climbing, which I find super interesting because we've got a couple of species that have climbing ways of motility as well, and that will feed into design of fish passage structures, understanding how fish negotiate those. So there's research we're also doing into the velocity structures around different types of things in channels, essentially.
Is there like a temperature sensitivity to the swimming that you have to look at too?
There will be, yeah. So initially we'll just probably fix temperature and fix dissolved oxygen and look at a fairly simple set of experiments on different species and different sizes. However, in time we'd like to look at temperature effects and dissolved oxygen effects, because obviously as those change in the river and some of those effects are anthropogenic, then that also has an influence on fish migratory ability and the ability of fish to pass obstacles on their paths.
So looking in the future, what's an ecohydraulics topic that you think future generations will be better positioned to work on and solve?
This is one of the things I've thought about for a long time is the 2 and 3D hydraulic modelling has become computationally so much more accessible, even in the last 10 years, that I think we've reached a point where really the resource intensiveness of data collection to support those models is now the limiting factor. And I think with the remote sensing techniques that are coming through and the rapid way those are developing, that those limitations will fall away in the near future. And I think it's going to be a really exciting time to be able to do large numerical modelling exercises.
Right. What about though with like fish behavior? Because like if you work on swimming, do you think that it's going to be feasible to try to incorporate the fish more and understanding their behavior to put into the models?
I think so, yeah. I mean, that's like a long-term goal of the research that we're doing currently. It was something that I did a little of during my PhD. I built a dispersal model essentially that was initially just passive dispersal, but also build in some algorithms based on fish preferences for depth and their swimming speeds. And so with this research that we're doing now on New Zealand species, we hope eventually to be able to do some individual based modelling, incorporating hydraulic numerical models too. Yeah.
And is there anything else you'd like to add?
No, I think that's about
Very
it.
good. Okay, well, thank you very much. I appreciate it.